Okay, so we have another example here. Each month, the American household generates an average 28 pounds of newspaper for garbage or recycling. Suppose this is true, maybe not so much nowadays. Suppose the distribution is normally distributed with a standard deviation, of 2 pounds. So my first question is, if a household is selected at random, find the probability that it generates between 27 and 31 pounds per month. So this is, like I said before, all we have to do is directly go to a class calc with normal distribution that has mean 28 and standard deviation 2. So in my class calc here, I have it from before. So let me clear these, or let me clear one of them. All I have to do is do mean 28, standard deviation 2. And again, we don't need to see the picture, but if you want, I want to be sure that that's the values I had, 28 and 2. So if you want to see the picture, click on the magnifying glass here, and it takes you to that normal curve. It's centered at 28. Standard deviation is 2. So I want it to the left. It says, find the probability that it generates between 27 and 31. So if I did this in the old way, you would have to find the area to the left of 27, area to the left of 31, and find the differences. In fact, you have to convert both those numbers to z-scores, then go to the standard normal curve. But we don't have to do that, right? With using technology, you can just skip that part, as long as you know that that's possible, right? You might have to ask, they might ask you to still to convert to z-scores. But in short, you can just right here between 27 and 31. So that's the value, yeah? If you want to be sure that those are the values you got, that's the 27 and that's the 31, right? So the area is 62%, okay? So I have it here. I get a screenshot and put it here. And then the second question is, how about if I ask you what's the probability that the household selected generates more than 30.2 pounds per month? So it's the same thing, of course, then more than 32. So it says more than 32. That means I want to leave blank on this side and put a 32 on that side. Remember that if you leave it blank, this infinity here get shaded, got there. If I leave it blank, when you leave the cursor, it leaves 32. Sorry, it puts an infinity. So that's how it gets this area, and it's about 2%, right? 2.2%. So I have a screenshot here. Oh, sorry, I did it wrong. It says 30.2, not 32. It said 30.2. There you go. So it's 1356. Okay. So using the class calc or any technology tool, we can directly find out again. Okay, so we don't have to find the z-scores and convert the back way. Let's do another example. The AAA reports that the average time it takes to respond to an emergency call is 25 minutes. Assume that the variable is normally distributed and the standard deviation is 4.5. If 80 calls are randomly selected, how many will be responded to in less than 15 minutes? So I need to find two things. First, what's the area, right, to the left of 15, right? It says less than 15 minutes. So let's see, the mean is 25. So I'm in this one. The mean is now 25. The standard deviation was 4.5, so that goes in the second entry. Okay, this gives you the order, the mean and the standard deviation. So that's the mean, that's standard deviation. It's kind of the same values than before. So if I don't have to adjust this graph. In fact, I don't like it, then it gets very skinny. I like this one better. And I want to find less than 15 minutes. So the 15 minutes goes on this side, and I leave it blank on the other side. So this is what I'm finding, right? It's a very small area. It's and the probability or the area that is 1.3%, right? It's 0.13134. So I have that pasted here, I believe. Yeah. So the number of calls, now that wasn't the question, right? The question is how many of the calls will be responded to in less than 15 minutes. So that is, this is the percent of calls of the total. So if you have a sample or of 80, yeah, about 1% of those 80 will be responded in less than 15 minutes. So when you multiply this to get how many, it's approximately one call, right? It's very small. So just about one call, because it's 105. So it's it rounds down to 1 call. Okay, so this is the question here. So if the question is not about the areas, but about how many of something, you have to convert using the percentages, right? So now the last example, I made it now on the other side. It's the same data, same mean, same standard deviation, but now of 80 calls, how many will be responded to in more than 28 minutes? So now I have to find the area over here, more than 28. That means I'm going to leave blank this side and put the 28 on that side. So I've been saying that we don't need the graph, but the fact that we have it and you can click on the magnifying glass to make you look at it, sometimes it's too big. I don't like it, so I zoom out or change the scale. But anyway, the fact that you get the graph is helpful to see that you are getting the area that you want, right? So this is more than means the 20 is on the left, and you leave that value. So it's 25%, right? It's 0.25. So that's about 1/4 of them. So if you multiply 25%, and you can do 24, 20, 25, 25 if you round, that times an 80. It's going to give me 20 calls on your way. So it still rounds to 20, right? So the answer for the question would be about 20 calls. Let me just write that down. Okay, so that's, oh, sorry, you would, for a problem like this, you would show your work doing, copying what you typed, normal CDF from, sorry, not normal CDF, the command in Class Calc is normal dist. You will type, write normal dist with a mean 25, 4.5. You're doing the CDF, and you're doing more than 28, so you're doing 28 less than equal to next, less than equal to infinity, and the answer was 0.2524. So you multiply that 0.2524 times 80, and you got approximately 20.2. So that's your answer. Okay, just to show what kind of work would you expect you guys to show something like that if you're doing this method.